Good morning, good evening, good afternoon. Thank you everyone for joining us for the day 2 of NCA analysis using R. And thank you for all those participants who submitted their homework assignments. In a little bit, we will hear more about the assignments, and the focus of today's workshop will be to go over the assignments. And Bill is also here with us, and he will walk us through the homework assignments, the solutions, and will also be happy to address any questions that you might have. Again, to tell you a little bit more, you already know this. Project Dontabhaktuni is the organization that is hosting today's workshop. And our motto here is to empower you to empower others. We are a nonprofit organization created to support scientists and students from around the world. What we do is to offer workshops, training programs, mentoring programs, and a platform for you to meet other scientists and students and work together so we can all grow and expand. How can you support us? You can support us by joining hands with us, by participating in these workshops, and learning from here. And our request is that you take on teaching what you have learned here to at least one more person. Also, please give back to the community and mentor others who can learn from you. I am Aruna Dontabhaktuni. I am the founder and CEO of PharmaPro Consulting, also the founder and scientific director of Project Dontabhaktuni. And it really warms my heart that we have all of you here with us to learn with us and to gain from us. Thank you again for being here. So just a little bit, extremely excited to share this, that we have had about 300 participants for this workshop. Again, you may not see all the 300 joining us today. Again, it's just the week before Thanksgiving here in the United States, and maybe just a week after Diwali in India. So there are participants who could not be here. So we are recording today's workshop, and this would be available for you to view after today on our YouTube channel. And of course, if you have missed any pieces, what is being covered today, or if you want to refresh what is being taught here, you can always go back to that YouTube channel and look at it. So that's what we make available for you. And please do share about us with as many people as you can. A few key points that we wanted to share, that we have a pretty diverse variety of participants here with us. We have participants joining from 30 countries, about 300 participants who registered for the workshop, and we want to continue keep doing the same work. And in the next month or so, we may be telling you about our workshops that are coming up in the future. These are our past workshops. If, again, all of this in workshops that we have conducted online are also available for you to access on our YouTube channel. Just going over a few of them so you can actually go back and look at them at your leisure. So without further ado, I'm going to stop sharing my screen and hand this over to Bill, so Bill can move us forward with regards to the homework assignments that were covered, and also go over the assignments and address your questions.
Thank you very much. Yes, I will like to extend my thanks to Aruna and the entire team that did make it happen. It is a great pleasure to be able to do this presentation, and I'm really very excited for the amount of engagement that we've had. As you mentioned, I should say, good morning, good afternoon, and good evening to everyone online as well. And yeah, so the main intent for today is to go over the hands-on assignment to cover any questions you may have that can either be part of the hands-on assignment or in terms of other aspects of PKNCA. Happy to go into the questions you may have. And I'll add that if you have questions afterward, please feel free to reach out. Either the most helpful way from a PKNCA perspective is to post a question on GitHub, because that is where all of the development happens for PKNCA and where we're able to, again, reach the broadest audience. When you have a question, someone else is going to have the same one later. So without further ado, I'm going to jump in to sharing my screen. The brief reminder is that the hands-on assignment had two parts. The first part was working on the steady state PK of amikacin in a killer whale and a beluga whale. I'm fond of these data sets just because they're somewhat unusual. I don't usually work with these species in my data, but the data itself are relatively straightforward in that it's two animals that received just a few doses intramuscularly, and then using those to generate NCA parameters. What we received last time, and you should be able to see my R window now, was the data set and some hints of how to handle the data, how to work through the data, but with some gaps in the way that it was set up. Here I have the final analysis built in, and this is on the PKNCA GitHub website. If you want to use the exact code that I'm presenting here. For any PKNCA analysis, you need to load the library in R, which is this first line here. Tidyverse is not specifically required for PKNCA, but it is generally useful for many analyses within R. And so I often load it even if it's not specifically required, just because that's the way that I code in R these days. As with any non-compartmental analysis, you'll load your data, and you should have received these files, I believe, by a Google Drive link. For people viewing the video after the fact, these are also available on the PKNCA GitHub website. So loading the concentration and dosing data. As with any data set, it's good to look at the data and make sure that you know what is in the data and how it is managed. The DOI link here is for the digital object identifier for the source article itself. I definitely want to give credit back to the people who did the original work to gather the data. And if you go to this DOI, which you should be able to search for anywhere on the internet, you can find the source article. The animal is equivalent to a subject identifier because there's one killer whale and one beluga whale in the data set. And then the time is the time since the very first dose. PKNCA in general can work with time in many different ways, but the way that I prefer to work with time most of the time is by time since first dose, because that enables PKNCA to look a little bit beyond your concentrations that you're specifically looking at if imputation or extrapolation is necessary. The concentration is the measured concentration. This was extracted by using the web plot digitizer tool to extract the information from one of the figures in the source paper. Time units, you should always be aware of your units, and I prefer to keep them in the data set rather than as data outside of the data set that you may need to know. So the time is in hours, and the concentration units indicated by this U at the end is in micrograms per milliliter. For the dosing, the animals each received 4 doses And what we're looking at are the data between the third and fourth, or after, sorry, the fourth dose. The beluga whale received 4 doses at 12 milligram per kilogram, and the killer whale received 4 doses. So since we're only looking at the first 6 rows, there were 4 doses of 10 milligram per kilogram. In the original data, they estimated them based on allometric scaling and trying to achieve a target concentration. Then the actual parts that are the focus of PKNCA are how do you put these data into PKNCA? And this is where the core of the hands-on assignment came from. So this is possibly familiar if you were looking at the data from the slides from last time on how to put data into a concentration object. Is you use the PKNCA conc function, and then you give it a formula, an R-based formula that references columns in your data set. So I'm going to scroll up a little bit here, and you can see the concentration column is the name of this column here. The time column is this column here. The tilde between those two indicates that the left-hand side for concentration objects, the left-hand side is the independent variable, as with it's the dependent variable, which is the concentration here, and time is the independent variable. But you can, from a PKNCA perspective, you can, if you're just thinking of concentration, it's always concentration on the left, time on the right. And then this vertical bar here is the pipe symbol, and it separates the concentration and time from your grouping variables. And in this case, our grouping variable is only the animal, which is either the killer whale or beluga whale. All of these, everything in this formula maps to one of the columns in your source data set. And you give the data set by giving the data argument to PKNCA conc. When you run this, if there's an error in your data set, for instance, if your concentration data was text instead of a number, it would give you an error. If you have more than one measurement per time point per subject, then it would also give you an error. But if you don't see any message here, then that means you have successfully provided the information to PKNCA, and it's stored it in this concentration object. Next, you do the equivalent for the dose information. So looking back to the dose data frame, you can see that the dose amount is here. The time, and so that's given equivalent to the concentration. The time is here, given the same way, again, as the concentration on the right-hand side of the tilde using R's formula interface. One important thing that often happens when you receive data sets, for instance, from a clinical study or with the SDTM standard, or from a non-clinical study with the SEND standard, is your time column may have a different name in your different data sets. And PKNCA doesn't care if time in the concentration data, the name of the column for time matches the name of the column for time in your dosing data. It just cares that they line up appropriately by the actual number itself. Then we have the same pipe symbol to separate the dose and time from the grouping variables, where in this case, we're just using the grouping variable of animal. And again, that's going to the column name in your dosing data set. You pass in your dosing data as d_dose. And with all of that, you again run it. You run that line of code, you get a dosing object. And if there are any errors in your data set that PKNCA is able to detect at that point in time, then it will tell you and hopefully it should give an informative error of what the problem is. If not, so like in this case, then it should just return and give you that object. And by the way, you can look at these objects where it will tell you some information about the object itself. For the concentration, it tells you the formula of that was used, so that you can see that this is identical to the formula here, just some added spaces the way that R formats it. It tells you that the data are for dense PK as opposed to sparse PK. PKNCA can handle sparse PK, though that's not one of the topics that we're intending to cover in detail in this session. It tells you that there are 2 subjects defined in the animal column. The word subject here is important. It's not just telling you that that's the grouping variable, it's telling you that's the grouping variable that PKNCA has identified as the subject. The default is that the last grouping variable is the subject. For instance, if you have study plus treatment group plus subject, then it will look to see what's the final grouping variable and choose that as subject. If you want to give it a different way, you can use the subject argument to PKNCA conc. Most of the time, people just let the grouping variables implicitly say what the subject is. It says the nominal time column is not specified. That may look a little bit unusual in this data set, since the times in this data set are all nominal times. But you can tell PKNCA a column to use for nominal times, which I sometimes use to use farther down the line in subsequent summary statistics, where you can then pull out nominal time because maybe you want a summary by nominal time point or similar. It doesn't have a significant impact on PKNCA at this point in time. However, there are future plans to use nominal times in more detail. And then finally, it shows you the beginning of your data set, just the first 6 rows in this case. You'll notice that you have the concentrations you started with, DOI, animal, time, concentration, time units, and concentration units, and then it added 3 more columns. The exclude column is how you can include or exclude specific time points from the data set. For instance, if you know that one sample is in error, then you can add in that exclude column and put a reason for exclusion in to that column. The volume is used if you're doing some sort of interval collection, most typically urine collections, and you can give the volume so that it will then do calculations based on the amount excreted. Since these are all point collections, and specifically since we didn't indicate what the volume column is, which would again be another argument to PKNCA conc, it doesn't have any information in that column. And finally, duration is again for interval collections. You can give the collection interval. Since these are all point measurements in plasma, then there's no duration, and so it's just set to 0 for every row. Similarly, you can see the dose information gives an equivalent amount of some equivalent information when looking at the dose object. The formula used, that the nominal time column was not specified. If you do specify the nominal time column, it will give you the nominal time column name, and then the first 6 rows of the dosing data. Similarly, you can see that there's an exclude column here. It indicates the route of administration and duration, which would be used for a duration of infusion. I see 2 questions in the chat window. The first is, what's the difference between pipe, plus, and slash? Let me just copy that question over so you can see the symbols themselves. What's the difference between these 3 characters for grouping? And because you've seen them all and they seem to do different things. The pipe symbol, the vertical bar, is used to separate the concentration and time from all of the grouping information. And so what you would do to use the pipe symbol is your concentration column, which can be named anything, but is the column to the left of the tilde. The time column, which comes after the tilde, immediately after the tilde, and this would be the actual time, or more specifically, the time you want to perform NCA calculations based on. Then always next would come the pipe symbol, and that separates out the grouping information. If you had multiple different layers of grouping that you wanted to do, then you could give all of those different levels of grouping with the plus symbol. So it is a little bit made up here to use DOI, but let's pretend that you may have had several different papers, so you have several different DOIs that you extracted information from. You could use DOI plus animal. And the reason that you would do that is you wanted to separate, maybe you had 5 studies of amikacin administered to killer and beluga whales, and you wanted to summarize each of those separately. Then this plus symbol gives you another level of grouping. PKNCA is fine with that. And it can take arbitrarily many levels of grouping. If you have 1 for just the subject level of animal in this case, or if you have 50, then it can take as many as you want. The slash, so the plus separates different levels of grouping. The slash it was originally intended to be used a little bit differently if you had many analytes. And so let's say you had, and we don't have multiple analytes in here, so this won't work. I'm just going to type it in to show the example. But let's say you had the analyte of amikacin and a metabolite of amikacin, and they were in the analyte column, then you could give it that way. The original intention within PKNCA was that you would then get separated out summaries, and that still is possible, but it takes a little bit more manual effort. In general, the way that I see people do it for the most part is like this, where they would give the study or treatment or any other summary. The analyte then comes somewhere in the middle, usually next to last, or sometimes first. That just determines what order things are sorted in the summary tables, but it doesn't affect any of the underlying calculations themselves. And then finally, animal. The next question, I'm just going to again paste this into a notepad window so that people can see it. Was someone used that this code where the order of the arguments is different. Specifically, they put the data first and then the formula second. Actually, going to switch this back. And I think the implied question is that okay? And this is just a general thing with R. If you name your arguments, then you can give them in any order you want. And so, yes, this is exactly the same from an R perspective, and you can definitely use that. The next question is, how do you specify the dosing if you have an IV infusion and its duration? So in that case, I'm going to paste this in. You can say route equals intravascular. And duration equals the name of the column that has your duration in it. So let's say the column were named EXDUR, and I choose that because that's often used in STTM datasets. But then if I run this code, I'll do it right now, it should give an error saying that the EXDUR column was not found. Okay. Subtly different error, but it first created the duration column, but then found it was missing, and so gave this error. If you add the EXDUR column, and then run this. It now doesn't give you any errors because what you did is you said dosing is intravascular, the duration is in the EXDUR column, and I created a column called EXDUR that says it's implicitly one. It said it's implicitly 1 hour. And definitely please keep the questions coming. All right, so then what you have, so once I've refreshed back to the original answer toward the original question. And what I'm doing here is I'm combining the concentration and dosing data objects. What you'll notice is that I didn't tell it what I wanted to calculate. That's one of the things we talked about last time, is you can give the intervals where you say these are the specific parameters to calculate. When I'm using PKNCA, 9 times out of 10, I do provide the intervals to calculate because I want to give the specific information of what I want to calculate in which time interval. In this case, I didn't, and so what PKNCA does is it looks into your data set for your concentration and your dosing information, looks at the time of dosing, the time between doses for each individual, and then will automatically choose some general items that you usually want. You very often want Cmax, Tmax, AUC, and it looks to see if you might have concentrations measured after multiple dosing and would add in half-life. You can see exactly what it's choosing by looking at the data intervals. And here you can see that there are 2 rows and it has an entry for each of the 115 parameters that PKNCA has. But when you run the NCA calculation itself, and I realize that there's a lot here, but the most straightforward thing to look at is, let's just look at Tmax here. Cmax and Tmax, where it says, yes, you want Cmax because these are set to true for the Cmax column, and Tmax set to true. There are other parameters that we'll see in a second, and you can see that the start and end times for are 72 to 96 hours because that's the time in window where we had concentration data. I'll just show the concentration data set one more time. So 72 to 96 hours for the killer whale, and then it's the same, even though we're just looking at the first 6 rows of the data here, but it's the same interval of time for the beluga whale. When we perform the NCA calculation itself, it finishes relatively quickly, and if you had any sort of errors or warnings along the way, it will show those here as you're running the NCA calculation. You pass in your data object, which has the concentration and optionally the dosing data in it. You can then look at the summary. So as you may recall from last time, the summary shows you the summary statistics of each of the different parameters, tells you what the start and end time are. If you have more grouping variables than just subject, then those will stay in the summary data set. We'll see that in a little bit, in a minute. And then it tells you N is the number of subjects who are contributing to the data set. And then what it automatically chose to be calculated are Cmax, Tmax, and AUC last. And the value for AUC last is 223 with a geometric as the geometric mean, and the geometric coefficient of variation is 12.7%. Cmax is similarly 37.3 with a geometric coefficient of variation of 13.9%, and Tmax is 1 for both, with as the median, and the range is 1 to 1. Same 1 hour time point was the maximum. The reason I know it's these summary statistics is from the caption argument down here, which says AUC last and Cmax are geometric mean and coefficient of variation, and Tmax is the median and range. Those can be set using the PKNCA set summary. Those more detailed settings are in PKNCA vignettes that are available on the website. And I don't intend to go quite at that level of detail in today's session. I see that there are a couple of questions in the window. I'll get there in just a second. I want to just show two other details first, and I'll jump back to the questions. So I said earlier that it pays attention to what the subjects are, and by default, it drops the subject from the summary statistics, because then it's more of a listing than summary statistics. But in this case, that's probably more appropriate, that since it's two animals and we're specifically just looking at the PK of those two animals, maybe we want to look at every single animal separately. And so drop.group tells to drop one of the grouping factors and give it an empty vector, and it will say it will not drop any groups. The default is it drops the subject level group and keeps all of the other groups. And so now what you see is that the grouping level of animal is retained in the summary table. And now you get what in effect is each of their individual parameters that were calculated. And these are just for the, just for the parameters that you specifically asked for. And you can see that it indicates NC, or not calculated, for when it didn't calculate the, for instance, in this case, geometric coefficient of variation, because you can't calculate that with one value. And finally, this is how you get out summary. Those are how you get out summaries of the parameters. If you want to get every individual calculation that PKNCA did, which in this case is no more than what we asked, then no more than those three parameters, then you can use the as data frame method. But for instance, if you calculate half-life and you only ask for half-life, it has to calculate lambda z. It has to determine the last and first point for the lambda z calculation. It has many other, it calculates the adjusted R squared and many other parameters. And so all of those would be listed in the individual calculation method here, whereas you would get only see the ones you specifically asked for, or since we didn't specifically ask for any, the ones that PKNCA inferred that you probably wanted based on this data set. All right, so jumping back to the chat window, there's a question: why do the killer whale and beluga whale have the same DOI? The DOI is, let me show that one more time. The DOI is an indicator of a journal article, or it's a little bit more general than that in practice, but in reality, that's what most of the time it's used for. If I search for the DOI, then it will take you straight to the original paper. And so the reason that I have this that same DOI is because all of the data comes from this one paper. And so that's just an indicator of where the source was. It doesn't have anything to be, it just has to do with where the source material came from. The next question is, if I specify D-dose data, the intervals cannot be specified. Kindly advise me on how to use both the interval specified and D-dose at once. I believe I understand this question, but if I don't answer you the way you're asking, if I don't answer the question the way you're trying to ask, please ask a clarifying question. So PKNCA data, if you just run it by giving it the concentration and dosing data, then what it's doing behind the scenes is it's looking at these first two objects and it'll accept concentration and dose in either order, concentration first or dose first. But then if you want to give the other, if you want to give the intervals, you need to specify that the intervals argument. So let's say we want to have the start at 72 hours, the end at 96 hours, and we want Cmax and half-life. Then what you would do is you need to tell it intervals equals my intervals data set. My guess is that what you are, that you may have not given it the name intervals equals here. And if you don't specify that, because of the way that R works, with the ... coming before intervals, and this is a subtlety on R, then you have to give the name for all of these other arguments. That's intentional because I don't want accidents to happen where someone tries to give the intervals as the dosing information, for instance. But now if we do that, you'll see that the intervals, while we only specified two things that we wanted, Cmax and half-life, once you put it into OData to generate your data object, it expands out to all of the different parameters because it does a check to standardize what parameters you're looking for, and it expands out to everything that you may want. And then you can try and calculate the half-life, but it says you can't calculate it because you only have 2 points after Tmax. You can change whether it's after Tmax or if it allows Tmax in your half-life, but because we have so few data points, it doesn't calculate it for you. And so here you can see that the Cmax is calculated, but the half-life is not calculated. No summary statistics are calculated for the half-life. Then the next question was, why is the result for Tmax 1 hour instead of 73 hours to match the concentration data? The way that PKNCA works is it works within the dosing, within the interval for calculation. So it's looking at your data set, and you said you wanted to start at 72 hours. So Tmax is relative to that starting time. If you said start at 72.5 hours, then Tmax would be, again, relative to that starting time. So instead of 73 hours, if you said 72.5, it assumes that what you're looking at there is is typically the dosing time. And that aligns with the way that people typically look at the data sets themselves, at the analysis results themselves, which is Tmax is the time of maximum concentration after the most recent dose. And if it said 73 hours, then many people would infer that it took 73 hours for the drug to absorb and reach its maximum concentration. So it does that under the hood to try and make it easier to interpret the final results. The next question that popped up is why are the summary statistics for half-life arithmetic mean and standard deviation, but Cmax is geometric mean and geometric coefficient variation? These are just, in my experience, the way that people typically summarize them. Some people also use the harmonic mean, but it comes from the way that for the half-life, it comes from the way that the data are generated, meaning the way the Cmax tends to have a geometric distribution. Half-life in reality has a theoretically, many people believe that has a harmonic distribution, which means it's an average of rates as opposed to an actual arithmetic distribution. But the subtlety there is usually relatively small, and more, as I experience it, more people tend to summarize with the arithmetic mean. You can change that with the PKNCA set summary function. There's another question. There was an error asking me to enter the duration in this code. However, the same code is working for me. What's the difference? And I think the underlying question is the can it be how can you control the duration? So you have to give the duration, has to go into the dose object. It doesn't go into the data object. My guess of what happened was I did this rather quickly in the example earlier, but I changed the dosing data information where I gave it the duration. I did something like this. And my guess is that you may have not given it a data set with the dosing information, sorry, with the duration information included, but I'm not exactly certain based on the question asked. All right. With that, I'm going to jump on to, unless there are other questions that pop up, and if people are still typing questions or thinking about them, we can jump back to this example. But I'm going to jump on to the multi-dose data that was the other part of the hands-on exercise. So to start off with, I'm going to restart my R session, and that's just so that everything is clean and I'm starting from scratch. It's often a good idea to restart your R session to make sure that you're doing things in a reproducible way. Again, I'm loading tidyverse and PKNCA. And here I'm going to load the concentration data. The directory on your computer may be different, but the underlying idea is just however you get your data into R, load it in that way. As always, it's a good idea to look at your data set and see what is there. In this case, I'm going to do one more step, and I'm going to look at the concentration object. And this is using some tidyverse functions. This is nothing specific to PKNCA, where I pull out my time and day columns. And then unique says only give me unique combinations of those. And then I want to arrange, sort is what arrange does, the data based on the time column. So we can just see what's there. Since this is actual time data, you can see that there are a whole lot of different values, 0, 0.25, 0.27. And this is the way that actual time data tends to look in real data sets. But overall, I'm going to scroll through relatively quickly, but you can see that there's time 0. There are a lot of times going through 5, 7, 8, 9, 12, and then around 24 hours, so a little bit before and a little bit after. And then there's time 120, and then many other measures that are around 120, 21, out to 144 hours. And then the times that are started at 120 are on day 6. 6 is the numbering that is typically used in regulatory data sets where day 0 doesn't exist. Everything starts on day 1. So while 120 hours is the 5th day, it's counted as day 6 in those data sets. That is unimportant for PKNCA. It's just a way to think about it. And in case you are looking at this after the fact and wondering why 120 hours is 6 days, that's where it comes from. So then this is similar to one of the questions that came earlier about the order of arguments. It doesn't matter. And so I gave the data first in this case. And similarly, let's see, if we go back to look at the top of the data set here, you can see that we have concentration, which is specified as conc. This goes back to one of the topics we mentioned last time, that the column names don't matter. In terms of PKNCA can use any column name that is in your data set. And then by time, and so that's going back to the time column down here. And then in the previous example, we had animal number was the indicated variable, whereas now it's called subject. And before it had text of killer whale versus beluga whale. Now it has numbers that start at 1. And PKNCA only cares that values are different and not what the values specifically are. It is best practice to make sure that you don't have missing values in these, but PKNCA, if you leave a value as missing, it will just look for is it different and work with it. This is the part that what you were trying to do as part of the assignment, is give the specifics for what values to, when to calculate and what to calculate. And to me, the core of the difficulty of this layer of the hands-on assignment was figure out what to put in the intervals. So looking at the data set as we did earlier, let's go back up here just a little bit. The time started at 0, and for the first period of time ended at about 24 hours. You'll note that no one has a value that is exactly 24 hours. It's 23.85 to 24.08. And what PKNCA will do for some of the parameters, but not all of them, and that's intentional, is it will look outside of the time interval that you specified to interpolate, or it will extrapolate to that last time point. And that happens for the AUC int parameters specifically. They are, if you're looking for a specific interval of time, you always want to use the AUC int parameters. This AUC int is AUC int based on extrapolation using AUC infinity, and the obs means using the observed C last value if you have to use AUC infinity. In this case, all of the different all of the different types of AUC would work the same way. And that's because all of your concentrations at the 23, actually, no, they would not all work exactly the same way. Apologies, let me take half a step back there. For the subjects who have measurements that are just after 24 hours, they will all work the same way. For the subjects who have their last measurement just before 24 hours, then if you use AUC int based on C last, then it would calculate your AUC up to this, for this individual, it would be up to 23.7 hours. And then that last 0.3 hours, so 18 minutes, would have been calculated as 0 because it's extrapolating using the C last method, where that's your last observed time point, stop. And for AUC all, it would end up doing something, again, a little bit different, but the best one for this particular example, and in my opinion, in most cases, is using the AUC infinity, because it'll give you that last bit of extrapolation most of the time the way you're intending it to. The other parameters that we wanted, as specified in the example up here, was we also wanted Cmax and Tmax, and we want half-life on day 6. So Cmax you just set to true, Tmax you set to true, and then for half-life, you do half.life, and I believe I mentioned this in the previous session, all of these parameter names are in the PKNCA parameters vignette. There are, as you saw earlier, there are more than 100 different parameters. One of the areas I'm working on actively in PKNCA right now is simplifying that. That'll be in an upcoming version of PKNCA. But since we only, for this particular example, since we only want half-life on day 6 and not on day 1, we set it to false for that first interval of time and true for the second interval. Here we can look at it and see the start and end of the start and end are 0 and 24. AUC int obs is true for both. Cmax and Tmax are true for both. And then half-life is only true for the second one. A question from the chat window is there an advantage to using the end time of 144 instead of infinity? And actually, it's not just an advantage, it is effectively completely different. Using the end time of 144 or it's completely different for the AUC int parameter, because then it will try and extrapolate all the way out to infinity for the AUC int. Whereas if you use 144, it only goes to the 144-hour time point. Usually, for multiple dose data, you would use the end time of one dosing interval after your last measurement for most of your measurements. An even better way to do it, now that you're bringing it up, is to have one more interval that then goes to infinity, and then this is outside of what was intended for the course, but it's just gives a little bit more context. Then you want to calculate these AUC int values for the first two intervals, and then not calculate it for that interval to infinity. And then you do want to calculate it here. I'm going to pause for just 1 second to turn off a speaker that's giving some background noise on my end. 1 moment. Sorry for that interruption. And what this will do is you now have 3 intervals. The first 2 are where you're wanting to calculate your AUC for the interval of time that's a typical dosing interval, and then the last one would go to infinity. In this particular case, because all of your time, because the last time in the data set is 144 hours, it wouldn't have made a difference because it's still including all of the time points, even going to 144. But better practice is to have a separate interval for that last time, the last time span, that time interval that calculates the half-life in case you had longer measurements. That is what PKNCA will do if you just give it the concentration and dosing data and you ask it to automatically figure it out for you. So then here, we didn't give it any dosing information. So whenever you don't give it dosing information, it gives this warning. The warning says no dose information was provided. Calculations requiring dose will return NA. So for instance, if you were looking for clearance, you would not be able to, you would get missing results for clearance because clearance requires dose. And you can summarize your results here and see that your Cmax on the 0 to 24-hour time point was, or interval, was about 8.6. For the 120 to 144 is 10. The coefficient of variation is here. Tmax is median and range, and it tells you all of the different summary statistics that were calculated down here at the bottom. Any other questions on the second example? Okay, well, if people are still thinking on that, oh, here we go. Would AUC last and AUC int obs be different in this case? And the answer is no. So the idea here would be, what if you calculated AUC last, and we can just do it and see what the results look like. And you can see that AUC last here is 74.6 versus 115. The order of the columns are different just based on what's required to do each of the calculations. So that's why it's showing up here. But 74.6 to 115, and oh, actually, sorry. for the second part, it is the 115 is the same because everyone has that 144-hour exactly as their last time point. Apologies that I was misremembering the source data set. Because of, let's look at the concentration data one more time. And there was the subtle way that AUC last comes in differently, but it comes from knowing your data and knowing how the calculations are being performed under the hood. So here, all of these subjects that have times, their approximately 24-hour time point is after 24 hours. AUC last does not look beyond the end of the interval of time you specify. So since the time specified is 0 to 24, AUC last, if the time is anything greater than 24 hours, it stops looking. And so all of these subjects who had measurements after 24 hours, their last measurement would be their probably their 11 to 12-hour measurement. And so that entire time, from 11 or 12 hours, or whichever was their last prior measurement, until 24 hours, because it's AUC last, would be 0. And so it is different for that first day, because everyone on the last day has a measurement that is 144 hours, and that's because this is a simulated data set and generated with simple and generated so that there is 144 hours. Then the AUC, then they're both the same on the last day. Another question is, could you please go over a bit on deployment in Shiny or another application? That is a bit beyond what would be part of this course. There is a Shiny app called Ruminate that does use PKNCA to perform non-compartmental analysis calculations. It is available on CRAN, and you can use it. So here's the link to it. The easiest to go here. So the Ruminate website is here. The easiest way for me to remember it is if I just search Ruminate CRAN, then it will take me to the right place. There is an online, yes, there's a version of it that runs online here. So if you run ruminate.ubiquity.tools, and you can use this to load your data, do various data transformations, visualize your data, perform NCA, and the app info, I believe, gives the system information on versions of R and similar. But that is outside the scope of what this session is intended to go on to discuss. Another question is, paste this into a notepad window so everyone can see it. If the data set contains the concentration time data all the way through 144 hours and enough dense PK to calculate the AUC for every 24 hours, is there an easy way to specify this, or do you need to specify each interval in D interval? The most straightforward answer to this is if you give the dosing information, if you have the dosing information and you give the dosing information to PKNCA, it will calculate everything for you that you're wanting and asking for calculation. If you don't have the dosing information, honestly, the simplest way is probably to generate your own dosing information. And let me I'll try and do this one on the fly. We'll see if this is the kind of way that often hands-on hands-on sessions can kind of get a little bit mixed up. We'll see what we can do. So let's say I'm making my dose information and we have dose synthetic, meaning I'm just typing it in. And so I make a data frame where I give it as time, as a sequence. SEQ is just an R function that gives you a sequence of numbers from one value to another. 0 to 120 by 24. And so now we have a very simple data frame that just has one column for time and 0, 24, up to 120. I didn't give 144 because the way that this data set is set up, it in theory would end at 144, but you can go as long as you want. There's nothing different about that. And then O dose is PKNCA dose, and then tilde time data equals D dose synthetic. And you'll note that this looks different than the way we were doing, than the way we were using the time earlier, where it, where I didn't give a dose to the left and I didn't give any grouping variables. All I'm doing with this data set is I'm saying that doses happened at these times. I'm not telling PKNCA what amount the dose was. Was it 10 milligrams, 30 milligram per kilogram? I'm just saying doses happened at these times. And then for my my PKNCA data object, which combines the dosing and the concentration, I give my dose and I don't give the intervals. And now what it has done is it has automatically generated the intervals, and this is going to be very long and wide. Show it for 120 to 144. It should have to look into this a little bit. There's something it should have also given. It should have also given 0 to 24. I'll have to look into why that isn't happening right now. But it is giving you all of the times for all, it's giving you all of the PKNCA calculation. It tried to determine what the optimum intervals were, and then it's doing the NCA calculation. For reasons that I'll have to look into, it didn't detect that it should gather the data from 0 to 24, but it automatically calculated. And so if you have regularly spaced concentration measurements and regularly spaced doses, then you can generate it more easily. I'd say that most of the time when I'm working with clinical data, that I generate my intervals manually because the using actual times, it just works a lot better to generate them manually. Another question says that the question says to specify interval as 0 to 120. Why did we enter 24 and infinity? Let me paste this into the notepad window again. So let's go up. Actually, let me figure out what I just did there. Okay, so what we're doing here is we're saying the start is going 0 to 24. The question asked to calculate AUC interval on day 1 and day 6, and AUC interval, Cmax and Tmax, and then calculate half-life on day 6. And so this, using this method here, let me just show this in an easier to view way than the way you pass it in. you're saying that on day one, all the way back to the infinitive answer. On day one, we want, and on day 6, we want AUC inf obs, so the AUC interval extrapolating using AUC infinity observed, Cmax, Tmax, and we don't want half-life when we have an end time specified, a finite end time specified. We do want half-life when we're going from 120 hours out to infinity. And so we used 24 as the end time to indicate the end of day 1. We use the 120 to 144 to indicate the interval of time for day 6. And then we use 120 to infinity to indicate the end time, to indicate the everything we have for day 6 for half-life. In this case, because the last measurement for everyone is 144, it would have been the same to use 120 to 144 and set half-life to true in the second row. Does that answer your question? While other people are thinking of questions, I'm going to jump to the topic of how to ask questions in the future, because I think that part of learning is not just attending the webinar or listening to the video after the fact, but also knowing as you're using it as you're using the tool in real life, where to go for questions, where to ask various questions so that you can use it effectively in the future. I'd say the most straightforward way to find PKNCA information is if you search for PKNCA and GitHub. I'm going to do a general search because I do it often enough that Chrome already remembers it for me. But if you search, and it'll take you here to the main GitHub page for PKNCA. And the most straightforward way to find information and learn about it is to use the vignettes. So I'm going to open this link here. That's buildany.github.io/PKNCA. Open that in a new tab. And the articles here are intended to be the user's manual. They are generally sorted in order for the first ones of what you may want to use to kind of go through as a reference manual, as a learning user's manual. And then the bottom articles are more intended for individual, for reference. I need to go for what are the options for controlling PKNCA. You're probably not going to want to read through that in detail, but you probably do at some point in time want to change something. And this tells all of the options that are used to control PKNCA and what their default values are. If you need to ask a question in the future, if it is a question, then the most straightforward way is to go to the discussions tab here and just click on, well, if you find something that's already what your question is looking for, then go here. Otherwise, you can click on new discussion, and this is just generally how you use GitHub to ask questions. If you have found a bug, then click over here on the issues tab and click on new issue. In general, if you're uncertain whether it's a bug or a discussion, then it's often better to start in. It kind of doesn't matter which one you start in, and I can move it from one to the other based on whether it's a bug that was found or a feature request. If there's something that you need help on, or you think would benefit everyone to have in PKNCA. Then two more questions that just came up in the chat window are, how do we use the PKNCA validation tool? If you go to the code for PKNCA and you go into the vignettes here, there is this particular vignette which you can download. and it will, and you need to install PKNCA a little bit of a different way than normal, because by default, PKNCA does not install, by default, R does not install tests for packages, and to validate PKNCA, you need to install the tests. So you need to install it using, probably too small for anyone to see, using this command here, but it is listed at the top of the vignette. If you're using the version from CRAN, you would use this. If you're using the version from, if you need to install from GitHub, you would use this command. You would use the GitHub version if you're needing something newer than what is on CRAN. And then it will automatically run the vignette on your local system, which runs through every PKNCA test, and then gives you a report on how it works, on did all the tests pass or not. I've never seen any of the tests fail for PKNCA before, so I don't think that would be a problem. I don't anticipate any problems, but if you ever have a problem with the validation, then please let me know. The next question was, does PKNCA automatically generate a report? and reporting is outside of what PKNCA does. There are, one of the things I found early into working on PKNCA is things like reporting and graphing are areas where everyone has many, many different opinions, and I would spend all of my time answering questions about formatting and less time actually getting the tool working a way that works for everybody. So I've intentionally kept those aspects outside of PKNCA. And I think the last question looks like it's, the question says to specify the interval as, oh, sorry, I actually already answered that one. Oh, sorry, the last question is, please, what is the reason we don't want half-life when the end time is specified? So I think that question is getting to the fact that half-life is set to infinity versus 144. The underlying answer there is the way that the intervals work within PKNCA is, for most parameters, it only looks in that specific span of time that you have specified. In this particular data set, it wouldn't matter because the last measurement is always at 144 for every individual. But in most real data sets, especially ones where you may have multiple dosing and then collect some samples out beyond the dosing interval, it may, the data may go beyond 144 hours. And so if you said the start and end time are 0 and 144 and calculate the half-life, and you had a sample at 240 hours, then that 240-hour sample would not be included in the half-life calculation, and you probably did want that in practice. I think that looks like everything. So again, thank you all very, very much. I've really enjoyed training sessions. I have enjoyed the engagement that we've had from everyone, both on the training sessions themselves, the great questions that have been asked during the training sessions, and I hope that you enjoy using PKNCA. Please definitely use it. Let me know how it works for you. Ask questions, contribute to the discussions, answer questions for other people. If you know, as mentioned at the beginning, the goal is to pass on the knowledge that you're gaining here to others. So please do.
Thank you again, Bill. Thank you for being here. Thank you for all the work that you have put in to create PKNCA to begin with. And really, it has been our honor and pleasure to have you here and do this workshop. Again, a workshop of this size would not have been possible without the contribution of our sponsors and the individuals who work behind the scenes to make this possible. A big thank you to Bill, and I also want to take the opportunity to thank our sponsors. Our sponsors for today's workshop are Gilead. You do know Gilead as a pharmaceutical company. They have been extremely generous in contributing to make this possible. Another of our sponsors is PharmaPro Consulting. Just to tell you a little bit more about PharmaPro Consulting, we are a consulting company that support pharmaceutical companies with their drug development needs. We support data management and programming, PKPD analysis, strategic advice, PKPD modeling, simulations, PK analysis. We also do support regulatory affairs and CMC regulatory. We are a women-owned organization, certified to be so, and these are some of the clients that we have supported. And also want to take the opportunity to acknowledge our volunteers and board members who have been a huge proponent to make this possible. Also a big shout out to Dr. Rajan. He has been our avid advisor, always been there with us. All these workshops would not have been possible without support from all our board members and volunteers. And a few important pieces, again, thank you to all of you who have been extremely accommodative. I know we had the day 2 of the workshop scheduled for earlier in November, but we moved the dates because we got feedback from many of you. Some of you had issues with R, some of you had issues with getting access to homeworks, etc. So we eventually moved the dates to accommodate all your requests. And I'm glad that today we are concluding this workshop session. As I had mentioned, and as you have seen in the emails as well, each individual participant is required to turn in your assignments. And you should have received an email with a Google form in which you have to turn in your assignments. If you do not have that, please reach out to us. You have our email addresses and let us know. And in some cases, you may not have gotten emails from us because you have blockers or other reasons. In that case, please go to our website, that is Dontabhaktuni.org, and get that link from there so you're able to submit the assignments. With today, we actually conclude this workshop. We are giving you 2 extra days just in case if you're having any technical issues to submit your assignments. Go ahead and do that. And please spread the word to your fellow participants who may not have been able to make it to today's workshop. And our objective is that you gain from this. Once at the end of this week, we will actually get the total number. We will also review the assignments if needed, and you will receive a completion certificate from Project Dontabhaktuni team. Thank you again for being here, and thank you for giving us this opportunity. And we do have few more minutes for this workshop. If any of you have a direct question that you want to ask of Bill, please raise your electronic hand. We may be able to unmute you and you can ask the question of Bill. So, giving you a few minutes to do that. And Jayashree, are we able to unmute participants if they have any questions?
Yes, Elena, I have given access.
Okay, great. And in the meantime, we will also look through the chat windows to see if there are any other questions that are out there. By the way, Bill, we get a lot of thank yous from the participants.
And I would like to reiterate my thank you to you and the entire Dontabhaktuni team for the opportunity and making it so successful.
And one more announcement while we are waiting for participants to raise their hands. We have another workshop that we had done in the past. And this workshop it's actually a training for finding the leader in you. This is for public speaking, also to develop your leadership. And this is in collaboration with IITs or Mumbai IIT that we have been able to offer these workshops. And if you have interest in that, please reach out to us via email. We may be able to offer you a scholarship. This is going to be conducted in India time, though this will be an online workshop. As I mentioned, I can bring you to that slide maybe so you can get to see what that workshop is. So this is that. It is a soft skills training that is attributed to bring up your public speaking, your communication skills, and your soft skills. If you have an interest in this, please reach out to us via email, and we may be able to offer you a scholarship. The sessions start from January 24th, if I'm not wrong, and that's a multiple day sessions that you have to attend. If I'm not wrong, I think they are like 30 hours or so. You complete that training and then you get a certificate for it. So I see that we have successfully answered all the questions here, Bill. And thank you again for being here and for giving us this opportunity. We really acknowledge you for taking the time and expanding your knowledge. And as we had shared earlier, please do teach someone else that what you have learned here. Any other announcements from our end, we will send it to you via email. Have a great day, all of you, and we look forward to seeing you in our future workshops.